yay. Yay for all of you who are good at math. That's right. I got 1 over 5 plus 1 over d sub I equals 1 over 2.5. And so d sub I ends up equaling 5 centimeters. So what did you guys get for the image distance? The magnification is -1. So what's the image distance? Or the image height, excuse me. Yeah, -1 also. Good, right? Magnification h sub I over 1 equals -5 over 5. So yeah, your h sub I is your magnification, which is -1. Here's the thing I want you to see. So what kind of image am I going to get? Inverted or upright? Inverted. Good. Let me prove that to you now in real life. Here. Here's my lens. Here's my object. Can you guys see the image on the board? Yeah. Okay. I am now going to take my finger and I'm going to be putting my finger in the way of the top of the object. And please look what happens to the image. Which part of the image am I messing with? Yeah, but I'm messing with the top of the object, so what does that tell me about the image? It's inverted. Yeah, it's inverted. Good for you. It's inverted. Okay, great. It is now time for me, since you guys are good at the math, it is time for me to show you the ray drawing. And the wonderful thing about the ray drawing is you do not need me to provide you with, mirrors or lenses. You can do this on your own. So I provided space below the problem for a ray drawing, but if you use that space to do this stuff, then just take out a separate sheet of paper and let me show you the process I want you to go through. Like I say, you don't need a compass to do ray drawings with lenses. They're a lot easier. Here's what you're going to do. First of all, get your straight edge and draw your principal axis. A nice long horizontal line. Please do that now. Wow. This guy here. Okay. Has everybody got a horizontal line, their principal axis? Okay, next, choose where your lens is going to be and draw a vertical dotted line through that point. Make it, reasonably big. This is the center line of your lens. Next, let's go ahead and draw the lens itself. They tell me that this is a convex lens, so you can make any shape you want as long as it's convex. There we go. There's my convex lens. Make it any shape you want as long as it's convex. Because here's what's happening. We're going to assume that these lenses are thin. And I think it's a good assumption. Look at this lens. It's a reasonably thin lens. We're going to assume the lens is thin. And so we're going to assume, even though the two sides might be different, we're just going to assume that all the refraction happens at the center line of the lens. So remember on your mirrors, where you had your rays hitting the mirror and bouncing off? And remember, with refraction, the refraction only happens at one place, the boundary line. Well, we're going to pretend that this lens is so thin that all the refraction happens at one place, the center line of the lens. So I'll even write it on the board here because I really want that to be a part of you. All refraction occurs at the center line of the lens. here's what I'd like you to do. We've got a focal length of 2.5 centimeters. Measure 2.5 centimeters to the left and to the right and get your focus there. Okay, you guys okay that that distance from the center line to the focus is 2.5 centimeters? And then go ahead and put your object 5 centimeters away from the center line of the lens. And make sure that its height is 1 centimeter. By the way, I'm doing 10-to-1 ratio. So by now you should have your principal axis, your center line of your lens. You just drew randomly a couple of convex looking thingies. 2.5 centimeters for your foci, 5 centimeters for your object. Are you ready for the 3 rays?
Yeah.
Is anyone not ready yet? Want to wait? Okay, here come the 3 rays. Remember how the first ray goes to the center and then reflects straight back? Well, we're going to assume that this lens is so thin and that the lens is so large compared to the object, I guess, that this ray will pass through the center of the lens and continue on unrefracted. Or you might say that whatever refraction this side above the principal axis does to the ray, this side below the principal axis undoes. So ray number 1, instead of going through the center of curvature of a lens, ray number 1 passes through the center of, the mirror. Ray number 1 passes through the center of the lens, unrefracted. So there's ray 1, passes through the center of the lens, unrefracted. Okay. Are you ready for ray 2? Here comes ray 2. Remember with the mirror, ray 2 travels parallel to the principal axis, then hits the mirror and reflects through the focus. This ray 2 is going to start off parallel to the principal axis. Then it's going to hit the lens, but only the center line of the lens. Not either of the surfaces, but just the center line. And then it's going to refract through the focus. Any question on either of these first 2 rays? The one that passes through the center unrefracted, the one that starts off parallel to the principal axis that refracts through the focus. The last one is going to pass through the focus, hit the center line of the lens, because remember, all refractions happen at the center line. And how do you suppose that ray is going to refract down? Yeah, parallel, just like with the mirror. And these 3 lines should totally intersect with each other. And if they don't, well, just edge it. And now, you can draw your image. And you can measure your image distance and measure your image height and see if it agrees. You know, because you're supposed to get an image distance of 5 centimeters and an image height of -1 centimeter. Let's see how close you guys got to that. I'm getting 5.1. That's not bad at all. I'm pretty awesome with a whiteboard. I did 10 to 1, so your 2.5 centimeters is 21 centimeters. Okay. How many people got like between 4.7 and 5.3? Wow, good for you guys. That's awesome. Okay. What's that? You got it right? Okay, so there's a few things I want you to notice. Do you notice, just like I showed you with the light, when I have a real image, the image is on the other side of the lens, is the object. Not like mirrors, where if I have a real image, the image and the object are on the same side of the mirror. Not so with lenses. The image and the object are on opposite sides when the image is a real image. And this is real. There's a real light rays put together to form that image. Okay. Hey, it's time for you guys to do another one. Ignore that bill. Please look at P3B. Try that one. And you can do it all yourself. Draw your principal axis, draw your lens, it's a convex lens, get your focal length, get your object distance and object height. Let me see if you can do a ray drawing for that one. Yes. It's P3B, part B is problem number 3.